Hi guys, so this is the second video on quadratics under Math SL. In this video I shall continue with questions that address the factored form of quadratic equations. This is a continuation of the previous video. I shall tackle the 4 questions on the screen in front of you, and I shall begin question 1 shortly. So question 1 came in paper 1, November 2005, question 5. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. So you are given that f of x equals x minus p times x minus q, and you are required to write down the value of p and q based on the drawing, this graph right there. So from the graph we should know that there are two x-intercepts at x equals -1 and at x equals 3. And by x-intercepts we mean values of x for which y equals 0, or for which f of x equals 0. So we should know that when x is -1, f of x is 0. So if x is -1, what value do I put for p to get 0? So -1 minus p equals 0. So what does p need to have? What value does p need to have in order to make this equation true? Obviously, p needs to have the value of -1. Same thing with q. I know that 3 for x makes f of x equal to 0. So if I put 3 right there, I expect f of x to be 0. So what value does q need to have in order to make this proposition true? So 3 minus q equals 0. So what value does q need to have? Q needs to have a value of 3. So p needs to have a value of -1 and q needs to have a value of 3. So let's take a look at the written answer. Of course, it doesn't matter whether p is 3 and q is -1, or p is -1 and q is 3. And the corresponding factors shall be x minus -1, which is x plus 1, and x minus 3. In B, we are required to find the coordinates of C. So we should know that C lies halfway between the two x-intercepts due to the symmetry of the parabola. We already mentioned this before. If I draw a line down the middle of the parabola, it splits the parabola into two equal parts. Hence, the distance of C from 3, this distance, has to equal the distance of C from -1. Excuse me. So C has to lie halfway between 3 and -1. In order to find the x value of C, I shall take the average of the two x-intercepts. So 3 plus -1 over 2, which gives me a value of 1. Now, watch out, because sometimes the question asks for the x coordinate and sometimes the question asks for the coordinates. So if the question does not specify, you need to find the x coordinate and the y coordinate. So now that I've found the x coordinate, I just plug this value into the equation, which is right there, in order to find the y coordinate. So 1 plus 1 times 1 minus 3, which gives me -4. Hence, the coordinates of the vertex are 1 and -4. Next, I'm required to write down the y coordinate of B. So B exists when x equals 0. B lies on the y-axis, hence x equals 0. So I'm just going to plug 0 instead of x into my equation, and this gives me 1 times -3, which is -3. So take a minute to copy the answer down if you will, and I shall move to the next question shortly. So the next question that we shall tackle came in paper 1, May 2001, question 2. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. So we are given the equation y equals x squared plus bx plus q, and we are required to find the values of p and q given this drawing right there. So I observe that the x-intercepts lie at -2 and 3. So if the x-intercepts are -2 and 3, then the factors are x minus -2, which is x plus 2, and x minus 3. So these are the factors of this equation right there. So I can just expand the factors to obtain an equation, a quadratic equation, similar in form to the one given in the question. I shall expand these two brackets, obtaining this red equation right there, simplifying this equation to obtain the purple expression right there. So the purple expression is x squared minus x minus 6. And this is exactly the same as x squared plus px plus q. So what I do here is I compare coefficients. I look at the x squared. So the x squared is similar in both. So there's nothing I can do about it. Then I look at the x. Here I have px, and here I have negative x, which is -1 times x. So px has to be the same as -1x. Hence, p is -1. Next, I look at the third term, which is q. This corresponds to -6. Hence, q has to equal -6. This is called comparing coefficients. So take a minute to copy the answer down if you will, and I shall begin the next question shortly. So the third question came in May 2010, time zone 2, question 1. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. So we are told that f of x equals p times x minus q times x minus r. And we are given this graph right there. We are told that the graph passes through these 3 points right there. Of course, the first 2 points, the first point and the third point are evident from the x-intercepts, and the second point is evident from the y-intercept. So this is a bit redundant. We could have obtained these 3 points from the graph. So I need to write down the value of q and the value of r. So knowing that the x-intercepts are -2 and 4, we should deduce that the factors are x minus -2 and x minus 4. Of course, x minus -2 is just x plus 2. So since these are the factors, I can compare this expression to this expression right there. So I have x minus r and x minus 4, so r has to equal 4. And I have x minus q and x minus -2 or x plus 2. So x plus 2 is visualized as x minus -2. So q has to be -2. This is one way of obtaining q and r. Another way is similar to what we did in the previous problem, which is to say, okay, so I know that this is the x-intercept. So if I put x as -2, I should get f of x equals 0. So if I put -2 here, I should get 0 in f of x. So -2 minus q gives me 0. So what value does q have? So -2 minus -2 equals 0. So q has to be -2. Similarly, I know that 4 gives me 0. So if I put x equals 4 into the equation, I get f of x equals 0. So 4 minus r equals 0. So r has to equal 4. So this is why r has to be 4. Next, I'm required to write down the equation of the axis of symmetry. So the axis of symmetry is the line that splits the parabola into two identical halves, and it passes through the vertex of the parabola, which is either the minimum point or the maximum point, depending on the type of the parabola. So if I want to get the equation of this line, I need to get the x coordinate of the vertex, because this is a vertical line, and the vertical line has an equation of x equals something, x equals 5, x equals 1. This is what the equation of a vertical line shall look like. So I want to know x equals what value to put this into the equation. So the value is the value of the x coordinate of the point, which is the vertex of the parabola. And we've already mentioned that this is obtained by averaging the two x-intercepts, since the line exists halfway between the two x-intercepts. So I'm going to average the two numbers, -2 and 4, and this gives me a value of 1. So I know that the x-coordinate of the vertex corresponds to 1. Hence, the equation of the axis of symmetry is x equals 1. And I want you to be able to differentiate between these two concepts. Here, we've obtained the x-coordinate of the vertex. So the value of x at this point is 1. This is what we have in gold. However, what we have in red is x equals 1, which is the equation of the vertical line, which is the axis of symmetry. I realize that both are x equals 1, but the first x equals 1 has to do with the x coordinate, and the second x equals 1 has to do with the equation of the line passing through the vertex, which we call the axis of symmetry. So I hope you've understood the difference between this x equals 1 and the other x equals 1. Moving on, I'm required to find the value of p. So I should note that I've used these 2 points, but I have not yet used this point, which is the y-intercept. So what I need to do is I need to plug this middle point into my equation. So I'm going to substitute 0, -4 into this red equation right there in order to find the value of p. So I know that when x is 0, y is -4, or f of x is -4. So I shall plug -4 here. This is what I've done. And I shall plug 0 in instead of the two x's. So I have 0 here and 0 here. Hence, I have an equation that only has one variable, which is p. So -4 equals p times 2 times -4. Hence, -4 equals -8p. This is the equation we have in gold. If I divide both sides by -8, I get p equals half. So take a minute to write this down, if you will, and I shall begin the fourth question shortly. So the fourth question that we shall tackle came in paper 1, November 2014, question 1. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. So we are given a function f of x equals x squared plus x minus 6, and we are required in A to write down the y-intercept of the graph of f. So the y-intercept exists when x equals 0. So I shall plug x equals 0 into this equation right there, getting 0 plus 0 minus 6, hence the y-intercept is -6. In question B, I'm required to solve f of x equals 0. So I shall solve this equation equal to 0. So what I need to do is I need to factorize this equation. So x squared plus x minus 6 gives me x plus 3 times x minus 2 equals 0. So what values of x do I plug into these brackets in order to get 0? If I plug 2, I get 2 plus 3, which is 5, and 2 minus 2, which is 0, and 5 times 0 equals 0. Hence, if I plug 2 due to this bracket, I get a correct value for y, I get 0 for y, which is what I want. Hence, 2 is one of my solutions. And similarly, if I plug x equals negative 3, I get a 0 here, and a negative 5 here. I don't really care what the number is here, because 0 multiplied by anything is 0. Hence, negative 3 is also one of my solutions. So these are the two values of x that set f of x to 0. So these are the solutions of this equation. And graphically, these are called the x-intercepts. Next, we are required to sketch the graph of f. So this is the mark scheme version of the graph, and you should know that I have to circle the x-intercepts, which are negative 3 and 2, and they have to be based correctly on my answers. I have to circle the y-intercept, which is negative 6. And of course, the shape of the graph is a concave up parabola based on this equation right there. It's a positive parabola. So it's a parabola that is looking upwards, sort of like a U shape. And they also like you to circle the endpoints of your graph in ovals. So this is something you should also do. But you should definitely watch out for the x-intercepts, the y-intercept, and you should be aware that the vertex of this graph is negative. We've already mentioned that the vertex of the graph has an x-coordinate, which is the average of the two x-intercepts. So the average of negative 3 and 2 is definitely a negative number. To be exact, it's negative 3 plus 2 over 2, which is negative 1 over 2, which is negative half. You don't really have to calculate the x-coordinate of the vertex, but you should be aware that the vertex lies to the left of the y-axis, on the negative scale of the x-axis. So you cannot have the vertex here, for example. It has to be somewhere here. So you should watch out for this as well. So this concludes our question and our video. Take a minute to copy the answer down, if you will. And I hope you have found this video useful.